Hey everybody, and welcome to I Hate Chemical Engineering. Um, Today's video is going to be why does thermodynamics terrify chemical engineers, and how are we going to fix that? It's the intro to my Thermo series that I hope will kind of clear the minds, and clear up some of the confusion for most of you chemical engineering students. I remember when I was in school that the average grade in Thermo was something like a 12 and a 20 was an A. It's usually the first real serious class that you take after heat and material balances, your sophomore year in college. And it's usually not taught well. It's usually really esoteric, really math dense, mostly theory, in other words, shapes, letters, and not a lot of hard numbers. At least the way that it's taught. Now obviously through application you do get to a hard number. Energy in terms of hard numbers of joules. But in class, I remember doing a lot of derivations, ending up with a system of equations that I wasn't sure when to use and how to use them. I hope that we can clear some of that up through this course. I'm going to teach this course using the book Introduction to Chemical Engineering Thermodynamics by Smith, Ness, and Abbott. That's the book that I used in college. Now, I used an older edition, but what you'll see usually today in school are one of these two editions, the 7th or the 8th. I'll be working practice problems from the back of each chapter out of the 8th edition. Now, these problems will also be in the 7th edition, and I've ensured that. So if you have either edition and you're wanting to follow along, you can do so. Now, I hope that this will clear up, again, some of the confusion that we have in thermodynamics. And that's really my goal. I hate this topic and I love it because it is the basis of, kind of a chemical engineering degree. It feels like that's what distinguishes us from the other disciplines, especially Thermo 2. Thermo is usually broken up into 2 semesters. We'll talk about that here in a second. But what really bothers me is I got out of Thermo. Didn't really even understand what I even learned. Most of the stuff that I learned in Thermo 1, was stuff that I had already learned in general physics to some degree. And what I learned in Thermo 2 for sure, and most of what I learned in Thermo 1 went through one ear and out the other, never to be used again. I left with kind of a one-liner on what entropy was, not really having any understanding of what it really is. And then I also left thinking that internal energy and enthalpy are kind of one and the same, and unsure as to when to use one or the other. So, as an anecdote, I can tell you that it's not uncommon for this to be the case amongst even our most intelligent. My college professor, he told me at a banquet that he learned Thermo as an undergraduate. He took it just like me and you. And then he took it again as a graduate student. Then he taught it 3 times. And after the 3rd time he taught it, that's when he finally understood thermodynamics. Myself, I've read through this Smith, Van Ness, and Abbott book probably 3 times cover to cover, at least. And it's still, I'm learning new things every time I read it. It's some of the more dense information that, continues to evade me and evade my understanding. But I'm going to teach you all kind of, in a clear format. I think I'm really trying to set this class apart from every other thermo class I've ever looked at online, which they all suck as far as I'm concerned. And what I want it to do is to really dive into those topics that are very difficult to understand and take them, in bite-sized chunks, and make them, explain them in such a way that, hopefully instead of everybody going, what is fugacity? We'll be able to answer that question. So, again, we're going through Smith, Van Ness, and Abbott's Introduction to Chemical Engineering Thermodynamics. We're going to break this up similar to how a university would into 2 semesters. Not that, on YouTube that makes any difference. So let's just go ahead and write out what those semesters are going to look like. So semester 1, that's going to cover, basically different state variables, what they are, but not just what they are, but in particular these 3. So we're going to look at internal energy, enthalpy, and entropy. We're going to look at, the Gibbs phase rule, and that's just a single video. It's really not difficult to understand. We're going to look at PVT behavior. So that's like, talking about how do these 3 relate to one another. So we'll look at, equations of state, which, an ideal gas, versus a real fluid. Then we're going to, see where we go from there. Usually I think the course kind of between Thermo 1 and Thermo 2 will kind of teeter-totter about refrigeration. Right, we do a lot of like efficiency discussions during Thermo 1 and 2. Now, the next set of courses here is mostly going to be, mostly dealing with VLE. So semester 2 is mostly going to be looking at vapor-liquid equilibrium and everything that that entails. So that's going to entail, fugacity. That's going to entail activity. That's going to entail, all the different more complicated models. So, but we're going to leave it there, and that's going to look at the remaining state variables that we've not really discussed. So mostly Gibbs free energy. Now, of course, we'll define them in Thermo 1, what Gibbs free energy is, but you won't really find its usefulness until Thermo 2. That being said, if we can define thermodynamics, ending this video, we'll just define thermodynamics as the movement of heat, of energy, in systems. It is the basis for the design of our distillation columns, our energy systems, our power plants. It is a critical part of a chemical engineering curriculum, and I think it's important for us to all understand it in order to build upon the things that you'll learn in future courses like distillation. That's the prime example, is distillation, really. That way we can all just graduate and have a real understanding on what Aspen is doing, and not just rely on a McCabe-Thiele diagram and say that's about as much as we got out of our separations course. I'd like us to understand more and deeper about what underlies that McCabe-Thiele diagram, that XY plot. Anyways, the next video is going to be on the Gibbs phase rule and the difference. What is the state of a fluid? And if you all are interested, please like, comment, and subscribe. But I guess I'll see you next time.